Linear equations and absolute value equations. We recognize an equation by the equal sign it will have in the problem. A linear equation, all the variables will have an exponent of 1. So we're going to focus on linear equations with just one variable or one distinct variable. These types of equations, linear equations with one variable, most of the time will simply have one solution, but it is possible for them to have no solution or infinitely many solutions. To solve a linear equation with one variable, we begin by simplifying each side of the equation. We get all the variables that we're solving for on one side, preferably the left-hand side, and then we isolate the variable or solve for the variable by basically using the order of operations backwards. We get rid of any addition or subtraction, and then any multiplication and division. So example 1, we see an equal sign, so it's an equation. The variables, the n's, have an exponent of 1. If an exponent is not shown, it's automatically 1. So a linear equation, and even though two terms have a variable n, it's the same value, so only one distinct variable. Step number 1, simplify each side. Both sides are already simplified. You cannot combine any terms. You cannot simplify either the left or right hand side. So step number 2, get all the variables on one side, the left hand side. So I'm going to move that positive 5n over to the left hand side by subtracting 5n from both sides, leaving me 3n minus 27 is equal to 12. And now solve for n. Get it by itself there on the left hand side. Begin by getting rid of any addition or subtraction first. So the opposite of subtracting 27, add 27 to both sides. 3n is equal to 39. And finally, the opposite of multiplying by 3 is to divide by 3. N is now isolated. N is equal to 13. So we have one possible solution. We just want to make sure we did not make a mistake. So anytime you solve an equation, it's always a good idea to check your work by plugging it back into the original problem and make sure the left-hand side equals the right-hand side. And in this case, it does check out. Example 2, equal sign, so it's an equation. All the x's all have an exponent of 1, so still a linear equation with one variable. Begin by simplifying each side. The left-hand side, we need to distribute that 5, giving us 5x minus 15 minus 3x. Still simplifying the left-hand side, combine like terms, 2x minus 15. And the right-hand side, distribute the 2x minus 14 minus 1, and combine like terms, 2x minus 15. So now with step number 2, get all your variables on one side. Once again, I'm going to get them on the left-hand side, so move that positive 2x to the left. I'm going to subtract 2x from both sides. It cancels out on the right-hand side, exactly what I wanted, but in this case, it also cancels out on the left-hand side. In other words, all the variables that we're solving for canceled out. So if that's the case, that means one of two things. Either there's no solution to this equation, or it has infinitely many solutions. So even though the variables canceled out, we still have an equation. So you want to look at the equation and see if it's a true statement or a false statement. In this case, it's telling us negative 15 is equal to negative 15, which is obviously true, which means there are infinitely many solutions to this equation. If all your variables cancel out, then it would have been something like negative 15 is equal to 10. That's obviously false, so you would tell me there's no solution to that equation. Example 3. Linear equation once again. Step number 1 is already done. We cannot simplify the left or right hand side. So move that negative x on the right hand side over to the left. I'm going to add x to both sides. So 5x plus 18 is equal to 3. Subtract 18 from both sides. 5x is equal to negative 15. Divide both sides by 5. X is equal to negative 3. And example 4, linear equation with one variable. Once again, simplify each side. Left-hand side, distribute that 2, 4x minus 8 minus 7. Combine like terms, 4x minus 15 is equal to 2x minus 11. So we simplified each side. Now we want to get all the variables on the left-hand side. So subtract 6x from both sides, leaving me negative 2x minus 15 is equal to negative 11. Isolate the variable, begin by getting rid of that minus 15. So I'm going to add 15 to both sides, leaving me negative 2x is equal to 4, and finally divide both sides by negative 2, x is equal to negative 2. And once again, for each one of these, you should be checking your work, plugging them back in. Absolute value equations. An absolute value equation is simply an equation that has an absolute value in it, which most of y'all are familiar with absolute values. You know the notation, two vertical lines with a value in the middle. For instance, the absolute value of 3 simplifies to positive 3. And you know they're always positive. The absolute value of negative 3 is also equal to a positive 3. But a lot of students don't know what an absolute value actually does or why it's always positive. An absolute value measures the distance a number is away from 0. So if you look at that on the number line, positive 3 is 3 units away from 0. Negative 3 is also 3 units away from 0. So therefore, absolute values are always positive because distance is always positive. So getting back to an absolute value equation, has an equal sign, has an absolute value in it. The steps to solve an absolute value equation. Step number 1, we want to isolate that absolute value on the left-hand side of the equation. We do want on the left-hand side. And then we're going to get rid of the absolute values by basically rewriting the equation into 2 separate equations. And then just solve each remaining equation. So example 5, you see an equal sign, so it's an equation. The absolute value should stand out like a sore thumb. So absolute value equation, step number 1, isolate the absolute value on the left-hand side. It is. So we go on to step number 2. We're going to get rid of the absolute values by rewriting it into 2 separate equations. The first equation, just drop the absolute values. In this case, 2x minus 11 is equal to 5. The second equation, the left-hand side remains the same. The side with the absolute values still will not change. But the right-hand side of the equation, you're going to multiply by negative 1. So 5 times negative 1 gives you all negative 5. At this point, we got rid of the absolute values. What we're left with is 2 linear equations, which we just got through reviewing. So just solve each one. The first one, add 11 to both sides, divide by 2. The second one, add 11 to both sides, divide by 2. So 2 solutions, you have to have them both. If you plug each solution into the original problem, it will work out. 2 times 8 is 16, minus 11 is 5. The absolute value of 5 is equal to 5. 2 times 3 is 6. 6 minus 11 is negative 5, and the absolute value of negative 5 is equal to 5. So 2 solutions, have to have them both. Take the time to check each one. Example 6, absolute value equation once again. In this case, step number 1 is not done for us. The absolute value is not isolated on the left-hand side, so that's the first thing we need to do. Now we can't move something into a set of absolute values. You can't pull something out. So the way we're going to get rid of that minus 10 on the left-hand side is simply add 10 to both sides. In other words, move it to the right-hand side, giving us the absolute value of x plus 12 is equal to 20. Step number 2, now it's time to get rid of the absolute value. Rewrite it into 2 separate equations. The first one, just drop the absolute values. The second equation, multiply the right-hand side by negative 1, which gives us a negative 20. Solve each equation, subtract 12 from both sides, which gives us x is equal to 8, and x is equal to negative 32. Once again, 2 solutions, you'd have to have them both. Example 7, another absolute value equation. Step number 1, get that absolute value by itself on the left-hand side, subtract 18, leaving us the absolute value of 7a minus 52 is equal to negative 4. And right away at this step, once we isolate the absolute value, you should notice something's kind of strange going on. What this problem is telling us at this point is that an absolute value is equal to a negative number, which is not going to happen. Any absolute value we know is positive. So a positive is never going to be equal to a negative number, negative 4 in this case. So right away, you know there's no solution to this equation. Now, if you did continue solving this equation, you did not realize that at this point. You would continue solving it, come up with 2 solutions, but when you check those 2 solutions, plug them into the problem, neither one would work, which means you'd have to get rid of them, so therefore, no solution. So that's why it's still important to check your work. It's easy to make mistakes, but a lot of times it's easier to catch them. Example 8, absolute value equation. In this case, there are 2 absolute values in one problem. So we're just going to focus on eliminating one of them. The one on the left-hand side, the absolute value of x minus 14 is already isolated, so we're going to just drop it, drop both sets of absolute values in order to give us our first equation. X minus 14 is equal to 3x plus 2. The second equation, the left-hand side remains the same again, x minus 14, but we multiply the right-hand side by negative 1. Now there's two terms over there. We have to make sure we distribute that negative 1 or multiply every term on the right-hand side by negative 1. So it's going to become negative 3x minus 2. So at this point, solve each equation. The first one, subtract 3x from both sides. Negative 2x minus 14 is equal to 2. Add 14 to both sides. Negative 2x is equal to 16. So x is equal to negative 8. The second equation, add 3x to both sides, which gives us 4x minus 14 is equal to negative 2. Add 14 to both sides. 4x is equal to 12. So x is equal to 3. Once again, two solutions. You have to have them both.